Okay, we're doing some inverse review here. And there's a lot of identities. Inverses are one of the simplest ones. What goes with sine? 1 over cosecant. Who had that right? Raise your hand if you had that right. Okay, good. The cosine one is 1 over secant, and the tangent is not. Cotangent is correct, and the other one would not technically be an inverse, but you're right that tangent is sine over cosine, but it's not an inverse. It's good to know, but it's not an inverse. All right. How about just a quick review of this one? What if you had tangent of pi over 2 minus theta? What would that be? The cofunction, cotangent theta. This and this are like pilot and copilot, tangent and cotangent. All right, and the ones with the negatives, sine of negative theta is negative sine of theta. And the only one that's different, tangent's the exact same. What's the other one that's different? Cosine, you are correct. So cosine's the only one where you don't have the negative. And that's because cosine's positive here. Do the angle this way, it's positive. And cosine's also positive down there. Oh, student. And here, cosine is positive. That's why it's still positive. The other ones aren't, because tangent's negative here, and so is sine negative here. Okay. All right. How about this one? I'm going to give you a quiz on this, and we'll see how you rate it at Amazon.com, where they have a 5-star rating for all their products. Let's see if you'd be a 5-star product when it comes to identities. Number 1, and please, right now is an appropriate time to get rid of all notes that you have, like just from upside down or something, because you can't do this on the sheet where you took the notes unless it's up backwards. If it's upside down, that's fine. Upside down, I mean like you, not flipped over, yes. I don't mean like you can read upside down. I mean, yeah. Anyway, okay, number 1. This one you have to give me 3 things that you could replace tangent squared of theta with. 3 things. Tangent squared theta could be this, this, or this. If you only get 2 out of the 3, you'll get half of them. Technically, yes. We don't work. Pause for a moment. All right. That was question number 1. Here's question number 2. Can you tell me what could you put in for cotangent squared? There's only 2 things that are kind of normal. Put in for cotangent squared. Write down those 2 things. You do need the thetas. Now you've reminded everybody, and sure nobody forget. Okay, number 3 is fill in the rest of this chart. Sine of negative theta, cosine of negative theta, and tangent of negative theta. You just have to have the answers to it. Number 4. I'll throw a curveball at you, but you should be able to handle it. The secant of pi over 2 minus theta. Number 5. I'm a little OCD. Now it would have bothered me. So, and now they all have need a dot in the same color sitting right about there. I'm not going to do that. Okay. Anyway, number 5. Try to get something you could swap out for. I'm going to stretch you on this one. Sine, and I need 3 things. 3 things you could put in for sine. 3 things. All right, so how many of you think you found 3 things you could put in for sine? Ooh, there's a bunch, yeah. Good. And if you don't, then you'll be at a 4.5, which wouldn't be that bad. Okay. Would you please take yours? Hand to the person sitting behind you. That's kind of like making up a problem that. What if I, yeah, exactly, sine plus 1 minus 1. All right. The top one, this one's really important because tangent comes up a lot. Because why? Because it has a sine and a cosine in it. Okay, it can bring up lots of problems. So sine, sorry, I'm going to use purple for this. And tangent could be sine squared over cosine squared. That's one of your 3 things. You having issues? Okay. And the second one is tangent. The one with the tan is what we seek. So if you want tangent all alone, you got to get the one to the other side. And so it would be secant squared minus 1. And the third thing for tangent is it could always be 1 over cotangent squared. Now that's making up a problem. That's not the same as an identity, so they lose half for that one. Yes? Cotangent of pi over... No, because they're squared, those don't work. This kind won't work on with the squared thing. Yes? No. Okay. Let's go to number 2. Cotangent. That only has 2 things. 1 over tangent. You can't just make up a problem that equals this. That's different than identity. Okay. And there's another thing for this. Cotangent could be cosine over sine. And wait a minute. It's got to be squared over sine. Oh, there's 3 for that one. I should have had, but I only asked for 2. So if they did the one with the cot is cozy, so it'd be cosecant minus 1. That's a great answer. I just forgot about it. All right. So there's 3 options, but you only need 2. Number 3. All of these are negative except cosine. So negative sine of theta. Cosine's not negativized. And then tangent is negative. Okay. And secant. Secant 1 is cosecant. And a lot of people don't like those because they're not used to the CSC. They don't know what it really means. It means cosecant. And that's of theta. Only one answer for that one. And the last one, sine theta. I said there were 3 things. Were there really? Let's find out. First of all, 1 over cosecant. I think you should have had that one. Now it's pretty much a no-brainer. And then got another one. And then you're making up a problem that equals it. Oh, okay. Okay, sorry. Hold on. Say that again, then I'll write it down if you're serious. Oh, okay, I got you. Pi over 2, I just thought you were saying something completely different than that. And yes, that is one of them I was looking for. Okay, square, are you serious or not? Okay, so go ahead and tell me. Cosine, square root of cosine squared? Oh, 1 minus cosine squared. No, because this is not a squared, you can't, that would again turn it into a problem. You're taking something, taking the square root of it, and then it would equal this as an answer. That's not the same as an identity. Yes, sir? Cosine? I like that one. But it's not what I was thinking of, but I like it. Hold on. Cosine over cotangent. Again, it's a problem because the cotangent itself can be replaced with cosine over sine, and then you flip and multiply. And you got cosine sine over sine, and the sines cancel, or the cosines cancel, sorry. So, good idea, but it's a problem. It's not a identity. All right. And that's, bottom line is, I just plain screwed up. There's only two. It's those two. I thought there was three. I was thinking of something else. I was thinking of tangent. Tangent always has three things. But plain tangent, I could give you three things. All right. You can make problems. You can, like, say square root of sine squared or something. But give them a score. Give them a score out of 5. Those are the two I was looking for. If they had those two, they're good. If they made up another one, don't hurt them for it. John, sit. Okay. Sit, sit, sit. All right. Now I want to get a feeling for how well you are, how good you are at this. Sit. Could you hurry, please? Okay, and so how many of you, give me this paper so he can get back to your seat. Thank you. How many of you had the 5, the perfect, like you totally know your stuff? Okay, awesome. 4.5, still very good. Probably what I would have gotten because I make those little mistakes every now and then. How about 4? Raise your hand if you had a 4. Also still solid. Now, if you had worse than that, I know there's a few of you. Need practice on these. You need more time, quality time with your flashcards. Make some. I put some on Quizlet. They're on the Schoology site under Files and Links. Or if it's not there, I think I actually put it on the front page in this folder called Trig Flashcards. Okay, lunchtime. All right, so we're back from lunch and we're done with talking about identities for now. We can do something completely different. This is about sum and difference identities. You are not going to have to memorize this. It is going to be given to you. So don't even bother writing this down right now. It's okay. But let me explain them to you as I do them. Let's say that you had 12 times 15. Do you agree that that would be the same as doing 12 times 10 plus 5? All I did is break up the 15 into 10 plus 5, right? And why does that make it any better? Because 12 times the 10 would be what? 120. 12 times 5 would be 60. And the 120 plus the 60 would be 180. So I can tell what the answer is 180. It's better because I broke it in parts. Well, you can do the same kind of a thing with sine and cosine. So let's say, for instance, you wanted to find the sine of 15. Pay attention, please. Sine of 15. If you wanted to find the sine of 15, of course, you could do the same kind of a deal. You could do sine of 10 plus 5 if you wanted to, but that doesn't really help because I don't know what the sine of 10 or the sine of 5 are. And so I want to do it with stuff I know. Come on, somebody smart. 30 is involved, but I'm not, you can't say divided by 2. It's going to be something plus something or something minus something. Plus or minus, not times. Plus or minus, either way. There you go. And why would 45 and 30 be good choices? Because they are ones we know. We know 45s and 30s. You will want this at the top of your page in a minute when I give you your worksheet. You'll want the 45, 45, 90, 1, 1, root 2, and this is 45. Because if I ask you what the sine of 45 is, you got to be quick with it. And if you just look at this, you can go, oh, sine opposite hypotenuse is 1 over root 2. So if I ask you for sine of 45, 1 over root 2. What's cosine of 45? 1 over root 2. What is tangent of 45? 1 over 1. See how fast that is? So if you can do that, you can do this kind really easily. But it's not quite as simple as you think. You don't just do sine of 45 and sine of 30. It's a little more complicated than that. Okay? What you do when you break it up like that is you say sine of, hold on. Didn't want to move. There we go. That's equal to sine of 45 times the cosine of 30. And if there's a minus in here, you use a minus the cosine of 45 times the sine of 30. Did you notice a few things? First of all, this minus here is the same as that minus there. Second, that the 45 and the 30 are always in that order. And it trades off between sine and cosine. Sine and cosine, and then cosine, and then sine. All right, now that's why we don't make you memorize this, because it's kind of a little bit complicated. But once you have the pattern written down, at the top of the page, then it's easy to just plug these into this pattern and solve them. Yes. How did cosine get involved? It's just because the identity, as it's written, is that if any time you take sine of two things, and they call them alpha and beta, and if you want to do an add, you use plus, and if you want to do a subtract, you use minus. It's really simple for sine. That it's not just distributing this and this. You have to use cosine in with it. The pattern goes like this: sine of alpha, cosine of beta. There we go. And then whatever sign you used, minus, minus, and then you switch them around. Cosine of alpha, sine of beta. I didn't really answer your question other than to repeat this is just an identity that we know. I'm not trying to show you where it came from and how it got all developed. That would take the whole rest of the hour. And once you get this pattern, it's really pretty easy to do these. So, all right, let's leave this one up here. Again, the original one would have been sine of 15 degrees. And you have to be smart enough to know, what are the two numbers I know? 45, 30, and there's only one other number you know. 60. And actually, you can also do sine of 90 really easily, too. 90, any quadrantal is pretty easy. Okay, if you had to do sine of 90, in case you forgot, you go, this is what, comma, what, it's 0, comma, 1, and sine's the y, and therefore it's 1. So sine of 90 is 1. All right, so you can use 90s and 45s and 30s and 60s. We know all of those. All right, so we break it down into this times this minus that times that, and then watch how fast this goes once I have the two triangles written. Now, you don't have to draw this in each triangle. You're going to have this on one piece of paper off to the side on your other screen, so to speak, that you'll have always there. Anyway, 30, 60, 1, 2, no, 2 and root 3. There we go. So if I want to find sine of 45, what's the answer? 1 over root 2. Okay, what's cosine of 30? Cosine of 30, here's 30. What's cosine of 30? 3 over 2. And then there's a minus. And then cosine of 45. 1 over root 2. And then it's sine of 30. 1 over 2. A lot of math is pattern recognition. Okay, you just have to follow the pattern for this. And then these problems become really easy and actually kind of fun, honestly. They're totally different than the ones you've been doing. All right, then on the bottom here I have 2 root 2 on each of them, and that means I'll automatically have a common denominator. That's one nice thing. Common denominators will come standard in your new vehicle. And you have 2 root 2 on the bottom. On the top, 1 root 3 is just root 3, and then minus, and then 1 times 1 is 1. There we go. There's my answer. Do I have to simplify that? No, because they're going to ask you for exact answers. And as soon as you were to take one of these and turn it into a decimal, like the square root of 3 is like 1.37529, whatever. As soon as you stop your decimal, then you've rounded it, and it's not exact anymore. Okay, so bottom line is leave your answers like this. All right, now let's do a couple together. Here comes the worksheet. Oh, wait, one more thing. Cosine, again, these are all written at the top of the page. Cosine is different, and cosine of alpha plus b, I'm in the United States, I can use an A and a B instead of Greek letters. Cosine of a plus b it's a different pattern. It's cosine, cosine, and then sine, sine. Cosine, cosine, sine, sine. And the numbers always stay in the same order. So if it's A and B, it's A, B, and A, and B. And then whatever sign you use here for cosine, cosine's always the oddball, right? It does the opposite sign thing than the other ones do. Cosine's the oddball here too. If you start with a plus, then you should use a minus. Okay? Sine is normal, and if you start with a plus, you end with a plus. But cosine, if you start with a plus, you end with a minus. All right. That's the pattern for cosine. And then tangent is the same kind of counterintuitive sort of thing, where it exactly reads this. Tangent of alpha plus or minus beta is equal to, and on the top you have two tangents, tangent alpha, tangent beta, and it has this sign. It's kind of weird. It had a plus minus. It still has a plus minus here, but on the lower level, it has a minus plus. It seemed like just coincidence maybe that they had switched it around, but it is a reason. Do you get that this and this are the same sign as each other? And that one is the opposite sign as the other two? You get what I'm doing there? So the fact this is plus minus and plus minus means they're the same. The fact that's minus plus means it's the opposite of what the other two signs. Okay? And then the last is tangent, tangent. This tangent, alpha, tangent, beta. And again, I know these are huge. That's why we don't ask you to memorize them. We just have to be able to follow the little pattern. So it shouldn't be too hard. Okay, here we go. I'm handing these things out. Pause, we'll do that. Okay, so let's do one together. Let's start with number 1. We already did number 1 together, actually. So let's do number 2. Number 2. Number 1 we did in your notes already, so we don't need to show you that one. Number 2 is tangent of 15. All right, so if I'm going to do tangent, I got to look for the tangent little formula. You see the tangent formula at the top of the page. Do you remember that I was also telling you really wanted to make those triangles? Make those triangles quick at the top of your page or on your notes page. Make sure you got the 2 triangle ones. 1, 1, square root of 2 for the 45, 45. And for the 30, 60, 90, you got 1, 2, root 3. Those are going to come in really handy. Okay, so now tangent 15. How do I break that up? Well, first of all, you got to use a little bit of thinking here. That 15 could be something plus something or something minus something. Now, it can't possibly be plus because the two things smaller than 15, we don't know them. So it's going to have to be a minus. Get what I'm saying? It has to be something minus something making 15. Because otherwise it have to be like a 10 and a 5, and we don't know sine of 10 or tangent of 15 or whatever. So 60 minus what? 45. Very good. And we do know 60 and we do know 45s. All right. So now that will equal, and remember the pattern. Look for the pattern here. It's tangent plus or minus, but it's the same sign as whatever this was. So it's going to be tangent minus tangent 60 minus tangent of 45 over 1 and the opposite sign, 1 and plus, and then tangent, tangent. It's the 2 angles again. It really wouldn't even matter what order because it's multiplied. Tangent 60 and tangent 45. And now, I were you, I would just go over them and, like, in your head, figure out tangent of 60. Here's 60. Tangent of that is opposite or just square root of 3. So if you do it like this, it's going to get really crowded on your paper, but it's going to save you a little time. Tangent of 45, tangent's opposite over adjacent from one of those angles, so it would be 1. And then 1 plus, they don't need to do with a 1, obviously. Tangent of 60, here's my 60 again, tangent of that's root 3. And tangent of 45, tangent of this is a 1 again. And therefore I'm at root 3 minus 1 over 1 plus root 3. There's my answer. And it's exact because we didn't round anything. Get that one? Just follow the pattern. All right, now let's try to fight through sine of pi over 12 together. That's number 5. Sine of pi over 12. Would you agree that pi over 12 is pretty small? It's a really small angle. Because pi over 3 and pi over 2 were things that we knew. But pi over 12, that's really small. So that must be a big thing subtracting something smaller. Okay? So what could you break that into? Sine of what minus what? I'll give you a hint. If you want the answer to be in 12ths, make these both to be in 12ths. Now, just hold on. Raise your hand. Yes? Okay. If you change that to 15 degrees, it is legal. You will get the right answer. And it's really not a bad idea because it'll make your life a lot easier. But then you're going to have to handle changing 5 pi over 12 into degrees. You'll be able to do that. All right. I kind of like that idea. So how did you get 15 out of that, by the way? If pi over 6 equals 30 degrees, then pi over 12 would have to be half of that. I like it. So that must be 15. And if all of a sudden we're doing sine of 15, it's the exact same answer as number 1 was. Right? Okay. That's a cheating shortcut I hadn't even thought of. But it sure does make life a lot easier. Here's the other reason I could see that being actually fairly logical. Do you memorize the triangles as 30, 60, 90? Yes. And they're in degrees, aren't they? Otherwise, you're going to have to convert everything over to radians and go, what? It's not the 30, 60, 90. It's the pi over 6, pi over 3, and 90 triangle, and actually pi over 2 triangle. And that's going to be a little weird. So I don't mind. I like the idea. We can change it over to degrees. You're the first class that suggested it. I know, it's kind of cheating. But then we're really doing, since pi over 6 is 30, we're doing half of that. So we're going to have to times this. Anyway, it's going to be 15. So if you need a conversion, you go like this. You always could change these by multiplying by 180 over pi. And after you did all your reducing, you'd end up with 15. Okay, so let's see. 3 would go in here. 4 times and 3 would go in there 60 times. And then 2 would go in there twice. And 2 would go in there 30 times. And 30 divided by 2 is 15. Yay, I can do it that way. Okay. So the question was, can we change that to sine of 15? Sure. And if it's sine of 15, then you could really break it up into sine of 45 minus 30. It's a weird 3. Kind of like it. But anyway. Now you can do the problem with the 45 and the 30 all the way through. All right. Let's do the backside. It's kind of like Jeopardy. The backside, they're going to give you the answer. And you have to figure out what the question would have been. So let's look at number 11. Number 11 says sine of 42 cosine 15 or 17. And then it says minus cosine 42 and sine of 17. What is sine of whatever? Do you get how they're alternating? And only one of those, if you look back at the pattern thing, only one of them alternates like that. Which one alternates? So it must be sine of something. And then if you're smart enough to be in this class, you're probably smart enough to figure out that the 42 and the 17 are involved somehow here. What would I do with them in the parentheses? 42 and the 17, and what do you think? Because there's a minus here, we use a minus there. If this had been a cosine one, remember we'd use the opposite sign as whatever they give. All right, so then you just have to figure out what 42 minus 17 is, and I think it's 25? I think it's 25. So that's what the question would have been, and therefore that's the answer. Now, this is all about pattern recognition, recognizing the patterns that are given to you. All right, now this is a little bit obscene in the total volume of problems, so I'm going to have you skip a few. 1, 2, skip a few. You can skip 8. You can skip 9. You can skip 21 and 20. No, that's good. I like the one with the variables in it, so I got to leave that. Let's skip 19. 19 and 21. All right, now let's do one that has variables. Look at number 17 for a moment. Number 17 has variables instead of like degrees. I agree that you can see it's sine, cosine, cosine, sine. So can you tell on number 17 that it must be a sine? Because it's the alternating one, sine, cosine, cosine, sine. And then since it's got a minus in it, then you must be using minus. And then the only other thing is, you got 2 variables that you put in here and here. Instead of numbers, you just put in the 2 variables they gave you. What are the 2 variables? 3x and x. So you go 3x and x, so yes, it ends up being sine of 2x.